Welcome to our April Tracks Data Science Lab seminar. I'm Peter Leese. I direct the Data Science Lab. Today, we're going to be talking about using ChatGPT or other LLMs as your research assistant, or really to assist with various research kind of processes. And just as sort of way of giving context, this is really intended to be a fairly introductory view for people that are fairly naive to using large language models, and sort of pulling people. It seemed like this was maybe where some of the greatest introductory need was, as opposed to kind of more advanced kind of stuff with large language models. But I'll talk about that a little bit as we start to go through this. So to start out, I felt like I couldn't even really talk about this topic without the sort of context that I feel like is ubiquitous. I mean, at this point, pretty much every form of media is talking about some form of large language models or generative AI, both in almost hyperbolic positive, hyperbolic negative sort of manner. This is an opinion from a scientist, specifically an American sort of philosophical neuroscientist, that was published in the New York Times about 2 weeks ago. He had some very strong opinions about AI and its his opinion of its sort of increasing impact on culture. But he really tried to sort of exemplify this through what he said was its clear increasing presence in science. And so this is an image or a figure that has been circulated a little bit. This is from a study really trying to look at the presence of peer review, or the presence of use of generative AI in peer review. And so I've seen this reported in like the lay media, in a variety of ways. Usually the headline is sort of like generative AI increasingly being used to take over peer review and removing humans. And so this author sort of brought this image back. I mean, I think this is a reasonable thing that we should be thinking about, especially from a science and a peer review standpoint. The interesting thing that I feel like most of these headlines miss is the fact that this is actually only looking at conference-oriented peer review, and only for one specific AI conference over time. So I think people have been quick to generalize that, we're replacing the human element of peer review with generative AI covertly, but I don't think we can take that away from this image. It's still not, I think it's a fair thing that we need to think about, particularly in science and in peer review, but it's not, a great look for generative AI, or at least that's how it's sort of being presented. So in addition to talking about the bad, I think we have to talk about the really, truly bad. This is one of the second major points that neuroscientist brought up. This is a basic science paper published in Frontiers in Cell and Developmental Biology in February of this year. If you haven't seen it, this paper went viral within like 3 days of being published, for a variety of reasons. The first is that there was really some amount of speculation that large portions of the text were generated directly from generative AI, maybe with minimal to no modification or editing of the text. But then really the pieces, you might even not know the name of this paper. You may have just seen the images. So these images or these figures and diagrams are taken directly from the published paper. Like these are the images that made it both through the editorial review, the peer review. And so I'm not a basic scientist, but the criticism is multifold on this. So one, I mean, if you look at anything that has letters, it's clearly gibberish in English or any other type of language. But then, well, this roughly looks like basic science diagrams for cell signaling that I remember seeing. Most of the criticism was the fact that this like more accurately represented something like creating a powdered and sprinkled donut as opposed to like actual cell signaling. So both the letters, the words, as well as like all of the imagery itself was just complete gibberish taken directly, unmodified and unedited from AI, and yet it still made it into a published journal. And then this is maybe the image that you've seen. This has been everywhere. I mean, this went viral within like 6 hours of this paper getting published. So this is another image taken directly from the paper that's intended to illustrate the manner of harvesting the specific stem cells that were used as part of the like molecular research here. And I mean, it's not even necessary to point out the sort of anatomical issues with this, but maybe just for purposes of transparency, I will point out that the rat has an opposable thumb, which, as we all know, rats do not have opposable thumbs. So, you know, this author was presenting this. They were saying AI is terrible. It's going to undermine our culture, and look at all the terrible things it's doing in science already. So, you know, I think the rhetorical question is, why even use generative AI at all? And I think, you know, I hate to say that some of this is borderline histrionic, but you know, it's still early, and I think it's still hard to tell where things are going. But I think the thing that is pretty clear is there is a really excessive amount of both positive and negative feedback and thought and criticism about generative AI today. But from my own personal experience, I think across a variety of tasks, large language models really present some sort of transformative experience. Is it equivalent to like moving from slide rule to calculator? I don't know. Horse to motor, like pre-industrial revolution to industrial revolution. I mean, it's hard to say, and I don't want to sound like one of these excessive cheerleaders, but particularly on certain tasks, my experience has been it's just ridiculously transformative. And we'll start to look at some of those as we go through this more. I also have to point out that all of the images in this are actually generated by generative AI, because I have no artistic ability whatsoever. So the question becomes, again, why use generative? Sorry, I'm trying to balance admitting people and advancing slides. So, you know, why use generative AI at all? You know, again, my experience has been that given the right context and application, generative AI or large language models can manage to still be helpful and super accurate. Not across everything. I think there is still some amount of caveat emptor employed here. But the thing that I have found to be almost universally true is that they're incredibly time-saving, productivity-enhancing. And as I was saying, at least on the artistic piece, I mean, they are really useful when there's something that you need to do from a research perspective that you just have no skills or experience in. I think one of the questions that I get, or a counterpoint to this, is, but is it as good as? Like, okay, you need to implement some programmatic routine and you don't have experience in this. Wouldn't it just be better to learn how to do that and to do it the right way by like getting a book? Sure. But like, do you have 6 months to learn how to, I don't know, like program subroutines in Perl if you don't already know how to do that? Like, maybe not. And large language models present a way to do that in like an hour as opposed to months. That's a really useful trade-off, even if there needs to be some care or concern sort of balanced with it. So on this topic, it's also necessary to go through a fairly extensive amount of governance that exists with an academic institution. So if you are at an institution, most likely there have been quite a bit of thought and discussion sort of put into this topic. So at UNC, the Office of the Provost hosts relatively extensive best practices and direction on generative AI. So, from the Provost site itself, you can get to this employee resources page, but within that, they really offer direction in a variety of areas. So there's specific direction and guidance for the research community, specific guidance and direction for students, and also specific guidance for staff. And I imagine there it's really mainly focused on like using university staff using this for operational UNC purposes, as opposed to using it in an academic situation or in a research situation. So if you are interested in looking at large language models and using them in research, I would implore you to go out and actually read the Provost's page on guidance for the research community. I don't know that anything here is prescribed necessarily so much as attempting to be sort of instructive and informative. But it is there, and I think as part of UNC, we should be familiar with all of this. The other piece is when you're publishing, at this point, pretty much every journal, at least every journal, like from my experience in the biomedical science space, has pretty explicit editorial policies on generative AI. So both pieces of those, I would say, are somewhat necessary to be familiar with what your institution says, whether that's UNC or another institution, and also from a publication standpoint, what the journal says. And so now, just to give the first example, you can start to use generative AI in all of these sort of quick and easy ways. So I was just curious, how would a large language model summarize the Provost's guidance on AI for the research community? So I copied and pasted the entire page in and told me to summarize it in 7 bullets. And having read it and compared it, I would say this is actually pretty accurate, if not pretty complete also. So disclose generative AI use, maintain privacy, ensure accuracy and cite sources. I mean, just starting to be a quick example of the practical ways that I think people are starting to use this. Here's a bunch of text that I need to be familiar with. Can you summarize this into something that I'm going to read thoroughly? And then if that's still even too long, I think the major takeaways that you need to know are, so for one, for any of these types of tools that we're talking about today, which are only online browser-based tools, that's all that I'm going to talk about today. I think you really have to think of them as being completely data insecure. So truly, I mean, I don't mean this as exaggeration. Like if there is information that you would not fully walk around and disclose completely publicly, you should not put it into an online large language model tool. There's also, I think, a lot of focus on just being almost painfully and overly transparent about use of these models in any type of activity that you're doing, whether it's generating, whether it's editing. And this is true, I think, increasingly at like the local level. So if we use it in local UNC work, but obviously also in any sort of publication process, there's a huge amount of disclosure that is increasingly desired on this topic. But interestingly, I do find that it's pretty common across sites and institutions and policies that there is a somewhat different feeling and perspective on creating something from scratch using a tool versus a human creating something and then editing it, even in significant ways. It's not clear like what that's going to mean ultimately, but to me, it seems like that is already sort of 2 different paths and sort of treatments that happen in a lot of these policies. And I think the last thing that's important to take away, particularly if you're really naive or new to using these tools, is that these are really tools as opposed to solutions. Think of it as sort of like a hammer. You don't buy a hammer and tell the hammer to build your house. Tools are really modular and they're sort of tuned for specific purposes. So you can't get into a large language model and like tell it to write my manuscript or to, you know, generate this entire image. It's a bit like coding in that, you know, you have to break it down into modular completable pieces for that tool. And I think there is some work and learning curve in figuring out which of those sort of pieces are well suited to tools and how do you tee things up for those tools. But I have seen, I think some people sort of, again, somewhat naively assume that you can ask really broad questions with the intent of getting like an entire product out. And that is really not, in my opinion, what these tools are really best suited to doing. So again, just sort of for completeness sake, talking about some of these easy to access tools. So these are all online, these are browser based. If you've paid any attention to like, you know, tools that are out there or things that people are talking about, these probably look familiar. So ChatGPT by OpenAI is probably the first that sort of started a lot of this conversation nationally and internationally. So you can get access to ChatGPT 3.5 for free with an account on OpenAI. You can also pay for access to a more advanced version of ChatGPT, ChatGPT 4.0, which also gives you access to OpenAI's image creation tool, DALL-E. Microsoft obviously has a very close relationship with OpenAI, and they have really co-opted the ChatGPT models as the foundation for their Copilot tools. Microsoft's offerings, I feel like, have also been really confusing, or maybe just not communicated well. This came up actually in a large language model that some of us were having a couple of weeks ago. So you maybe even saw from UNC like months ago, there was something called Bing Chat Enterprise released. That is apparently the same thing as Copilot. It was just renamings and poor brandings. But so now Copilot, as far as I know, is the one and sort of only major large language model generative AI offering from Microsoft. We have access to that for free as a function of being an institutional license holder of Microsoft Office 365, like as UNC. That gets you access actually to a lot of things. So for our version of Copilot, we actually have access to ChatGPT 4.0 as well as DALL-E straight through our like free UNC access to Copilot. The thing that we don't have currently is the version of Copilot that can actually access your Microsoft stuff. This is a big part of Microsoft's business model, is that they can deploy Copilot in a way that it can see like all of your OneDrive files and folders or all of your documents in Microsoft Office. And then you can actually use Copilot to interact or potentially edit or analyze all of that information. That's a totally separate subscription model that UNC is not participating in, as far as I'm aware of yet. So when you use Copilot, it will basically just be the online version, not the version that can access all of our UNC stuff. So Google is also in this space. Their primary large language model is called Gemini, that's online. We'll also look briefly at a Google language model tool called Notebook LM. Adobe has really image-focused tools, as you know, and being part of UNC, we have fairly easy access to Adobe Creative Cloud. That's for certain people, I think like a free license. For other people, it's a very low cost license. But through that UNC licensing, you do have access to, at a minimum, Adobe Firefly, which is their image generative AI. There might be one or two other sort of like niche Adobe products for generative AI. But literally, I mean, this is, I want to emphasize, in no way exhaustive. I mean, this tool base expands literally. I mean, I wrote weekly and then realized it is more like hourly. Like it's impossible to keep up with all of the sort of startup and independent user sort of like remixes of models, creations of new models, applications, compilations of applications in this space. Oh, and I didn't mention H2O GPT. That's another tool that we'll look at briefly that'll become more clear what that is good at. It's also worth mentioning that in that Provost's webpage on UNC, they list a bunch of sort of tools broken into some categories for reference. They have some science tools, which are really mainly focused on literature review, presentation tools, which I'm not familiar with any of these. I imagine they're probably mainly slide focused. And then what they call productivity, which is sort of a grab bag of stuff. There is an interesting one called Tutor AI, which basically allows you to enter a topic, and then in theory, it creates a custom online course for that topic, which I can show you really briefly. I was sort of interested in this, but it actually requires an account to do anything meaningful. So all I've seen are like the high level initial results it gives you, right? So I want to learn about course and exact matching. And it gives you, these topics that in theory it does something on, but then you have to like sign up with it, which I have not taken the time to do. But I mean, again, I think from a purely like educational standpoint, this sort of concept for an AI is pretty interesting, right? I want to learn about PySpark. It gives you a bunch of things immediately to start looking at. If anybody uses that specifically, I'd be interested in seeing whether it actually works well or it's just sort of some fluff. Goes back to presentation. Okay. So, another thing that it's worth talking about because people ask about is, so these are, like really, accessible online based tools. Like, what about other ways of doing this? Like, what about using offline LLMs? So there are like lots of ways to do this and talk about this. This is an explosive field, particularly in the area of not just using large language models for research, but actually researching large language models. There are, a variety of ways to actually deploy large language models locally, offline. There are APIs, but all this stuff is just, I mean, out of the scope of today's conversation. Today, I'm really focused on, the use case of you are totally new to these. What's the easiest and fastest way to get things off the ground? I do have to point out, though, that just in the data science lab, we were talking, and currently we're thinking that we're actually going to do an offline LLM seminar next month. So an introduction to like OLAMA and deploying LLMs locally, and then maybe some more specific use cases for using offline LLMs. Okay, and so now we're actually going to get into some examples and use cases across a variety of topics for things that I personally use large language models for in my work and my research. So the first is in the room, the Zoom is blocking our view of the slides a little bit. So the first is really just pure like topic exploration, right? Learning. I would say in many ways, large language models have like replaced what I used to use Google for. So first we're going to look at OpenAI. And, like it's common that I'll be talking with someone and we have some topic come up and you're just trying to figure out more about it, right? So like, what are common ways of change? And so, I mean, if this is a topic that you know nothing about, I mean, I find this is a remarkably easy way to get from like 0% knowledge on a topic to like 15 to 20%, which is really powerful. Particularly in that it saves you from like just sort of dredging results across a variety of websites for an untold amount of time. But the nice thing is you can expand this sort of topic exploration pretty easily. So like, well, what about person exact matching? I didn't see that in your last. Okay, I didn't include that, but now let me easily tell you a bunch about this other method. And in fact, give me some advantages relative to the previous methods that I described. And so I think, you know, one of the things that people also ask me is like, well, what's the difference between like one model versus another? Like you did that in OpenAI, but like, what if, you know, you're missing something? What if that model happens to be tuned in some way and, you know, it's hallucinating or giving you something kind of specific? I personally use this other tool, H2O GPT, just as sort of a quick assessment of that sometimes. So this is one specific tool, but it's representative of a whole variety of platforms and tools that are sort of built the same way. It's basically an environment that has multiple models deployed simultaneously side by side that lets you basically look at, you know, testing something across models simultaneously. So for instance, currently what's by default deployed in this H2O GPT environment is Meta's Llama 2 70 billion parameter model, the Mixtral 7 billion parameter model, OpenAI's GPT 3.5, and then a Zephyr model that's pulled from Hugging Face. So again, let's just say, what are views of and then this is basically going to feed that to each of them. And then you can look at the specific results across all four models simultaneously to see, for one, like, does it seem like any of them are tuned in a specific way that's more or less helpful? And two, just thinking about comprehensiveness. So something else that sometimes I like to do is like, especially if I'm sort of trying to figure out like, okay, well, like, what's a specific package that I would use to do something? I often find that a single model is maybe not as comprehensive across, say, like a programming language as I'd like it to be. What are, whereas running it across multiple models, I find will usually give like incredibly comprehensive results. Okay, so like here, Llama 2 is giving me 1, 2, 3, 4, 5, 6. Okay, it's continuing to go. 7. And it's also interesting because doing something like this really lets you sort of easily and quickly just see firsthand the difference between um, what are ostensibly more complex models and less complex models. So for instance, looking at this 7 billion parameter model, um, it it really does a nowhere near comprehensive job of identifying like how would I do this or what packages are available, right? So it names 2, 3, um, but then it basically immediately jumps to like, well, or you could just do this totally from scratch by yourself. Whereas the Meta Llama 270 billion, I mean, it can much more quickly give me 1, 2, 3, 4, 5, 6, 7 specific, like pre-developed packages specifically to do this. Um, so again, when I'm looking for really comprehensive results or trying to look at comparisons, this is a type of tool that I'll pull up just to try and look across multiple models simultaneously. Um, Okay. So that was, again, I should probably say, just given the nature of this topic, my focus here is really on breadth of use cases as opposed to depth. So we'll look, just for like a couple of minutes across a bunch of things, but not go super deep on any of them. Um, the next sort of major area that I will interact with stuff on is really slides, and assisting with slides. Um, I have not found something that I would say is as good as I feel like it should be for helping with slides. Um, I'm really curious to see if other people sort of have better uses or better examples of this. But I'm just going to show the ones that I do sort of use for slides with LLMs. So one is the actual designer function or equivalent across actual slide tools. So designer is some amount of sort of generative AI built into PowerPoint that basically, based on the content of a slide, gives you a bunch of different design options. Right. So I have this pure text layout, and it is giving me a bunch of different options um, to just immediately switch it over to more visual examples. And so I do use this pretty frequently building slide decks, particularly like when you want a visual layout and you just don't want to take the time to like create a million images and then lay them out and insert the text and like all of the other just tweaking and fine tuning that it takes in something like PowerPoint. Um, I mean, the more full-fledged example is in Google, where Google does currently have the Gemini large language model just fully implemented across its like tool ecosystem, right? So like here I am in Google Slides, and I have the Gemini model just sitting right next to it. And you can ask pretty comprehensive things here. I just find the results to never really be as good as I would like them to be. So like here, let's say generate a splashy middle slide for a presentation on terms. And so there, I mean, the nice thing is, it actually gives you a slide, and then you can decide, okay, do I want to insert it? Would I like to regenerate it? Do I just want to discard it? But as opposed to sort of other models where you're really more like working piecewise by element, like let me fine tune some text in a model. Let me try and generate an image for a specific slide. This will give you a full-blown slide. The slide might just not actually be what you want it to be. So, I mean, it's also, I have to point out, there are like, this is clearly a really attractive use case across a lot of, you know, tools. There are a lot of people and companies that claim to have like amazing presentation generative AIs. Most of them either require like a subscription or some sort of explicit account to get created, um, which this is not a big enough use case for me to ever go to that length. So for all I know, there might be something out there that's like way better, and I just don't know about it. But at a minimum, I do use this to assist with slides to some degree. Okay, we can't talk about slides and then not talk about image creation. So image creation is some degree of a mixed bag. And I'm going to show Copilot here because Copilot probably gives us the closest to like an advanced image generation model. I'm going to try and give it some context too. In fact, I'm going to attempt to feed it the same thing that the authors of that paper. I mean, I'm sure they gave it something much more sophisticated, but we'll see how it can do at generating a medical illustration. Oh, I must be signed out of this currently. Let me try it in Gemini. Well, actually, I can just show you my previous example. How about that in testing this? So previously in testing this, I said, I didn't give it the context of you're a medical illustrator. I told it to create like a nature format style illustration. And I mean, you can get some sense. These are like maybe, oh, the image is expired. That's too bad. You'll have to just appreciate them in small mode. I mean, you can see it has like some baseline idea of like what a medical cell signaling illustration would look like. But I mean, these are basically the takeaway is generative AIs are like terrible for full-blown science illustration. Nor have I found a way to like feed it a real science illustration that you have and then sort of edit it to some degree. Yeah, so I make that point here, editing images. That also seems like a really great use case to feed it something, and then rather than tedious editing to have it do it, I haven't found a tool that does that. The thing that I have found that works and is pretty cool is actually diagramming. So I have an example of that somewhere in here. So for instance, and again, so the thing that this is where I get to the modularity and the tool focused piece. These AIs don't really understand, or they're not capable of saying like, make a diagram of X. What they can do is write text to generate that diagram in something else. So for instance, like using mermaid.js syntax, generate an example entity relationship. And so it's going to spit out all of basically all of the code that would be necessary to generate this diagram in Mermaid, as well as an explanation. Live. And there it is. So I just copied in all of the JS, the mermaid.js syntax, and let it populate this entity relationship diagram. This is, I mean, I make a lot of diagrams, so this is something I'm actively pretty interested in if it's a way of getting out of, like, again, going through all the tedium of creating lots and lots of very technical diagrams by hand. Similarly, draw.io, which is an XML-based format and diagramming tool, you can ask any of these AIs to generate diagrams or other types of images in like the actual draw.io XML format. So you can give it specifications, which you're asking for, ask it to generate the XML, and then you can copy and paste that XML into draw.io to get the type of chart or diagram that you're trying to get. And so then thinking about how to use large language models with literature and literature review, this has become, to me, a little bit more complicated recently. I feel like it used to be, as of a month or two ago, it was easier to copy and paste full articles into these online tools. And I feel like recently they've really limited basically the number of tokens or text items you can copy and paste into these. And I think there are sort of a lot of subscription-based tools that have cropped up now to sort of support that need. So instead, the tool I'm going to focus on is Google's Notebook LM, which is actually another tool that I find myself using kind of a lot that I sort of love. So in Notebook LM, this is again part of the Google generative AI and large language model ecosystem. But so this is a tool that gives you a workspace. It lets you create a virtual notebook. And then within that notebook, you can basically feed it whatever documents you want as sources. You can feed it something from Google Drive. You can feed it a PDF, a text file, or just copy and paste a huge amount of text. So what I actually have here is a paper that I wrote and published last year as the source, and then it allows you just to basically interact with whatever specific documents or text you've fed it as a source. And so this is new summarization text based off of the 2,000 words of the article, really just describing it. It's not copying, right, or like subsetting. It's generating this text. What's also interesting is you can ask this fairly detailed questions, but what I think is sort of interesting too is like some of the use cases for this. So like one instance is I was toying around with basically building a multi-source sort of companion to the Tracks Clark tool. And so now you can ask questions and it will compare across documents to give you questions or answers to your questions. So like here, let's say, we'll see if this works. This might confuse it. It might try to give me the actual full result. Oh, good. I was afraid it was going to try and jam all of this text into like a JSON formatted document. Okay, so here it's summarizing sort of a use case. I wanted it to both summarize and then give me basically like a reprex of like, here is JSON formatted random text that you could then feed back into this. But then just quickly, like another place that I use this is actually with documentation for programming packages. Like I basically never take the time. I basically read programming package documentation as necessary, as opposed to comprehensively. And so I just tested, like, what if I just load the entire PDF of, say, an R package in, and then use that basically to summarize and give me a workflow. So like, give me, so say I have that specific use case for this package, rather than sort of parsing the entire, I don't know, 40 pages of documentation, I can just ask questions and try and get examples for it. Oh, great. Oh, well, that's not what I was going for in terms of giving me an example, but you don't always necessarily get what you're looking for. I have used this before to actually basically give me reproducible examples. I must have used a different prompt to do that. But so again, that's very quickly this concept of sort of summarizing text and specifically narrowing your model to a specific body of text for use cases, whether that's scientific literature or something different. This consensus is a tool that UNC had pointed out. This is an example of more of one of these, like, I think subscription-based tools this is pretty interesting because in theory, like it has, its corpus as some gigantic body of literature. And then rather than asking really narrow questions, it lets you, in theory, ask like really broad hypotheses and then tries to give you some evidence base for whether, that thing is positive, whether it's negative or null. So like, let's see. Yeah, so we'll even see if this gives me results or if it just blocks it out with an add to subscribe. All right, so interestingly, there you go. According to this AI, ivermectin, based on a summary of 17 papers, has 2/3 consensus that ivermectin is safe, or maybe not safe, but effective for treating COVID-19. So I think I do not have experience with these tools. I think this at a minimum is an example that suggests you might want to be cautious of how you engage with some of these tools. Okay, moving on past summarizing text and literature. I'm not even going to give any examples of scientific writing. This I feel like is still so controversial and such a potentially fraught area. I just want to give some clear use cases that I do think are less controversial in its use for actually doing scientific writing. So one is doing something like you have a manuscript and then you want to edit, say, the voice or the person of it. From my experience, a large language model is pretty good at doing something like that, right? You have a manuscript, you need to change it from first active to third person passive. Like it can make those changes pretty well without having, like an author or a research assistant pour through every instance of the manuscript. I think there are some things that are more complex. So, right, like re-editing something for clarity or reorganizing sections of an entire manuscript. I've also had people tell me they use it to identify things like bias in a paper. To me, these are more complex, so I don't have experience with them. I don't know how well they would work. Something that has come up as another potential use case is like, you sort of write a manuscript and then you're left with the abstract. So generating an abstract or attempting to generate an abstract from the body of the manuscript, or generating a lay abstract. I have personally been stuck in periods of like spending far too much time attempting to translate an abstract into a lay abstract. And I think that might be something that a large language model could do much more quickly and easily, maybe even than a person could. Okay, so coding is really like the truly transformative thing with large language models, I would say. Um, I mean, there's no real way to demonstrate like the utility of this sort of actually getting in and doing it. So I would invite you to do this. But I'll just give some quick examples. I mean, my experience is without a doubt, any of these large language models is like probably a better or at least a broader coder than like anyone I've ever met. So let's just say generate a random 11 by 6 matrix in Python. Now do the same in Julia. Now transpose the matrix in Julia using a loop. So, I mean, the use cases here I find to be like almost unlimited. Like, so for one, for programming languages that you already know, I mean, large language models will definitely assist you in figuring out how do I do X, particularly if you can describe your situation of X pretty clearly. I mean, I would put it this way, like these models have basically replaced whatever use case I originally had for things like Stack Overflow. Um, but additionally, when you have a use case of like, I know how to do something in language one, but now I need to do it in language two, like to me, large language models are the first stop for doing that. So again, like for instance, like I don't program in Julia, but if I needed to do something in Julia, these models would at least give me the ability to get off the ground with them and then spend more time looking at it and editing it and sort of learning the sort of ins and outs of what's happening, as opposed to just figuring out like what is the syntactical call of like the single function, like the type of thing that you can easily spend an hour trying to troubleshoot formerly on places like Stack Overflow and pages of documentation. Um, these, from my experience, are also really great at debugging. I mean, these don't, these examples don't give me any errors, but were I to run something in another, in RStudio or in Jupyter and it threw an error, I mean, again, rather than Googling that error, my first place now is like I put it into a large language model and I let it try to diagnose the error for me and then debug the code for me. And again, that has been totally transformative from a time saving or productivity standpoint. And then the other piece is code conversion, right? So I have this thing that I already do in Python, but now I need to do it in Julia, copy and paste, and tell that you need that routine translated into this other language. And from my experience, it does that almost flawlessly, like a surprising amount of the time. In the interest of time and getting to some other really interesting things that I want people to see, I'm going to move on. So one of the things increasingly that I'm really interested in and that we've been talking about doing is actually generating synthetic data using large language models, and potentially across a variety of things. So the first is really focused on generating text for NLP. Clinical notes are really sensitive. It's hard to get those into places where we can do sophisticated NLP on them. But increasingly, there are ways of using models to generate synthetic text that we can do things with. And in fact, this is actually a paper out of Harvard really on this topic. I'm just going to demonstrate that as an example. So basically, they this is in their GitHub that I linked to, but you feed this, they fed this prompt that basically is like, examples of here, if I were a physician, I would document these things with housing issues. Now learn these and randomly remix those 58 times. And so here are just 58 different single sentences that could express a wide variety of permutations of how a physician or a clinician would document adverse housing situations in a clinical record. And so then this starts to give us a corpus of synthetic text with a specific issue that you can then feed back in and do things with. I mean, the thing that's amazing also is you can do things like now give me 10 sentences about housing issues, but also give me 5 sentences about random other issues. So now it's essentially created like a data set for me. I have randomly, I can take these, load them into another data set, and then randomly sample from it to get basically a natural language processing data set that can go into a variety of tools, both that would have potentially, say in this case, the social determinant of health that I'm interested in looking at, as well as other things, right? So you have what's essentially a labeled versus unlabeled data set that you can much more easily get to without hand labeling. Let's see, what else? Oh, another interesting example I want to go through real quick. Tell me about mortal time bias in So this is another example of, so say you're working on some sort of methodologic area. Tell me about this topic. Okay. Now create a example of exposure variables. You can basically take a situation, specifically like a methodologic situation, and feed it back and tell you to give basically like a reproducible example. And then it will simply go through and set up both the random data set as well as apply the method and create the variables. And in this case, it actually went so far as it looked like to apply the proportional hazards model for the ultimate analysis too. And so again, do I advocate like doing your analysis this way? I do not. But I mean, as a tool to either learn a method or to create a reproducible example to learn a method, or to potentially look at suggestions of how to formulate a coding structure for a method. I mean, this is, again, from my experience, really helpful and time saving compared to like poring over website after website of sort of random examples, trying to find the exact example you're looking for. In addition to, creating the synthetic data that you potentially need to test some of these things. Oh, one final interesting example. So computable phenotyping. So this is the process of identifying data or cohorts from really large databases. Um, a, so there we go. So here it'll actually write example SQL of like, how would I identify this cohort from a specific source database? And then you can get more restrictive with this too, right? Like I could ask it again now, like, okay, can you substitute some other specific criteria out for, say, medications? And it'll input that and then rewrite the SQL based off of that updated criteria. So again, I don't think this is something that gets you from 0 to 100%, but it can get you from 0 to 15% or 20%, or at a minimum, give you something to start working off of for specific use cases. And then there are a bunch of interesting other different use cases that I think are interesting, like in totally different areas. So there's this tool that you can upload basically a music file to, and it'll split it into component parts. This is potentially interesting because say you have a meeting with multiple speakers. This is something that lets you sort of split the different speaker streams into different audio files. And so potentially isolate a single speaker from others if you're actually trying to work with, say, like an audio recording of a meeting. Resemble.ai. This is synthetic voice generation. And so this is something that actually basically lets you create voiceovers. So if you're doing video work, I've actually tested basically pulling scientific abstracts out and loading it through here, and it works incredibly well. So audio transcription, summary of meetings. I mean, the use cases for these models has become like really, truly explosive. And there are even a variety of websites. So I list this one, there's an AI for that, that all it does is compile all of these various use cases or ChatGPT implementations for kind of like specific niche areas. And so there, I'm just going to stop. That's, again, a lot of breadth in a short amount of time. Happy to talk about any of this if there are questions. And again, I'll just highlight again that we'll be talking about really deploying large language models locally in applications like Llama next month in our May Data Science Lab seminar. And so I will stop there. And Kara, I guess I'll just ask if there are any chat questions that I should address at this point, or any questions in the room. Yeah. Yeah, I mean, so I think that my understanding of that is on the online tool. So the question is about for people on the Zoom, like length of document loading. And so my understanding is that's really a platform limitation on the online tools, where like you're limited in the amount of tokens that you can basically paste in. And that's where you sort of need to split it between but in these sort of like more specific tools, they're really loading like the entire body of text that you load into it. So like Notebook LM specifically, I don't know if there's a like a token limit or like a character or word limit. But I mean, I have loaded very, very large documents into that successfully. So like, let's see here. Like I have the entire Book of Odyssey loaded, which is, I mean, it's really large, and it accepts that entire PDF as an input. And so it's like retraining and processing off of that entire document. Yeah. Yeah, I mean, getting that amount of text into one of these other models is a little bit more complicated, to your point, like, either splitting between prompts or, other ways, like if you were using an API or something, you could feed it in like a little bit differently. Yeah. Mm-hmm.
Are you able to hear me on the Zoom?
Yes, we
Okay,
can
good.
hear you.
Okay, great. Just making sure. We have a question about if Microsoft Copilot is completely different from the GitHub Copilot.
Yeah, so my understanding is that they're the same. I don't know this for sure. Let me preface by that. But my understanding is that it's essentially the same underlying model technology. So like the same, parameter size or order of magnitude model, but then trained differently. So where I think GitHub Copilot is trained specifically on like GitHub, so like all of the repos or sort of explicitly coding focused pieces of Git or GitHub, that the more general Microsoft Copilot is trained on some other like expansive and broad like corpus of generalized documents across the internet. So my understanding is even if the model technology is somewhat the same, they're trained and then obviously deployed in different ways.
Another question is if there's any guidance that you know about for I guess making prompts or putting prompts into AI for research purposes.
I don't know about for research, but there are like lots of guides to like creating prompts and modifying prompts. And there's even some amount of work in sort of using the large language models themselves to like refine prompts. I mean, those I think you can, I think it was even just, I think it was Google that just released like a guide to prompt engineering. Yeah, there you go. And so I imagine there's some amount of guidance for like this for like all the different models, whether it's directly from the platform or whether it's from like more of an open community. Yeah.
The next question is asking if it's good to use AI to check the formatting of your sources on your manuscripts, assuming that something happened with the citation manager import.
Yeah, I have only seen that a little bit. I have seen people, like try to apply, say, like apply MLA style citation to all these references. So I've definitely seen it as a proposed use case, but I have not personally tried it. And in fact, I don't know how successful that is. I mean, it seems like a relatively straightforward type of use case. So it seems like something that would be like a reasonably good application. I just have no firsthand experience with it, nor any real like secondhand knowledge of other people doing it. Yeah. But it would be interesting to know what the experience is. I think it seems like it would probably work.
Let's see, the next one is, how do you know that AI produces real information versus false or hallucination information? Is there an automated way to verify the information being produced?
Yeah. I mean, I think that is a crucial question, like at the crux of a lot of this. I don't really know of an automated way of sort of checking for hallucination, which is not to say it doesn't exist. I just don't know about it personally. Um, and I do know that we have seen examples of, hallucinations even as large as like entire DOIs. So like asking a question, it giving, an evidence-based result, and then providing the DOI and the link for a specific like scientific paper. And in fact, like that paper does not exist. Like it just randomly generated some fake paper and a fake DOI reference, as the reference, the ID reference for that paper. I mean, I think that's where I thought about how I would phrase this, whether I would say like, when you're using these tools, you need to be cautious, and cautious felt like a little bit, I don't know, overly restrictive to me. And then I thought about like, does being mindful seem more appropriate? But mindful maybe didn't feel like cautious enough. I mean, I don't really know a better way of doing that, short of just sort of being like sort of, wary, or being mindful, again, to basically reiterate the words I just said I wanted to use and then decided not to use. I mean, I think you want to review what it's providing you. And if it's something that you're going to use in some meaningful way, then I think it really is the sort of due diligence piece is up to the end user to sort of figure out, like, is this real information? Is this a citation that actually leads back to somewhere? Or is it something that seems like it is not? I think, the particularly for something that we're going to use for research, we do have the responsibility of figuring out, is this reliable information that we could use? Similarly to, any of the other research processes that we would engage with.
I think we have one more question about if there's any other AI resources that will be offered by UNC, like ChatGPT, besides the consensus and Microsoft Copilot.
So I have no visibility into that. Basically, I only currently know as much as like what's on the provost's website. I have sort of gotten the sense that the School for Data Science is having some of these conversations about other platforms or other tools, but I don't know. I have no visibility on what those conversations are about or like where they are in those. Um, so I would hate to speculate beyond that, I guess I would say. Yeah.
Following up on that question, you mentioned that with Copilot, there is a subscription fee that would be allowing the user to then have allowed access for all of the folders and everything else that would be with Microsoft.
Yeah.
Are there other institutions that have maybe pursued that route with their faculty or staff that would allow them to streamline all their other documents that would be a part of their work life?
I mean, again, I cannot tell you specifically, like institution A has done this, let alone what that result is. But my understanding is that, yes. So like definitely in the private sector, I know a bunch of institutions have done this. I have sort of heard that some academic institutions have started the process of trialing it. But there's just a lot of sensitivity to it. I mean, both from a public institution standpoint, from the cost perspective, because I think the cost, the business model of this is something like $30 a month per user, which, I mean, over an institution is a fairly large investment. And I don't believe there's any sort of institutional level pricing like they do for something like Office 365. And then additionally, there's just a lot of sensitivity to, I think, the unknown, like private information that might be accessed in an automated way by some of these tools sitting on OneDrive or on like other sort of Office 365 kind of storage areas. So yeah, I mean, the most I've heard from the public institution side is that many places are thinking about doing it, including I've sort of heard the whisperings that UNC is even like, they know it exists. There's some level of consideration of like, is this a tool that would ever make sense or would even think about ever trialing? And I have heard that some institutions have moved to that point of trialing, but that is so far about all that I know. It seems like institutions have not been super open about like, here's exactly what we're doing and what our, you know, profile with it has been. I mean, it does seem like a lot of people recognize there's such a really large value proposition if these tools are good to deploy them back against like your own office infrastructure that way. And assuming they don't like, you know, expose tons of information either to Microsoft corporate or to some other, you know, place we don't want a bunch of sensitive information linked to. Well, great. I think, let's see, Kara, was that the last question?
I think
think
so.
so. Okay.
Yeah.
Yeah, great. Okay. Well, yes, thanks everybody for attendance. Hope you enjoyed. And feel free to go to our SharePoint site. We'll have information about our upcoming seminars. Join our listserv. Then you'll automatically get notifications about our upcoming seminars. And I guess the last note is if you came in person, make sure you have signed in if you haven't already at the sign-in sheet outside the door. We have to submit all of our attendance up to like our funding agency. All right, thank you.